with Kohler. This is an ASCO switch, so I'm going to be brief and kind of just go over simply the function of the ATS and what it's going to do. So this is an ASCO 300 series transfer switch controller, G-type controller. This is a pretty basic, pretty simple ATS, and there's one more back there. That's actually the one that's going to be tied into the elevator control. That is tied into the elevator control back there. So this screen is not going to give you very much. We see normal okay, transfer switch on normal. So it's in the normal position, we have power. You can see here we have utility power and it's connected to utility power. Now the generator runs, we're going to see a red light here, and if it ever transfers, it's going to see a red light here showing that it's connected to the emergency source. There are certain time delays we have in here. If you lose power, it transfers and everything works. When you guys get normal power back, it's going to take about 15 minutes before it transfers it back to make sure utility voltage is steady, to make sure that it is doing everything it's supposed to do. So if power goes out again, we're not having a lot of unnecessary transfers back and forth between normal power and emergency power. That's pretty much the only time delay in here. We can simply come down, we can look at voltage on the normal side. If the generator's running, we can look at voltage here. On the emergency side, no active alarms, serial number, software version, and that's it. There's really not much else to look at on this front screen. There are other menus. There is, I believe, we have event log here, which holds 161 events. It's going to tell you engine stop, transfer emergency to normal, normal source accepted, transfer normal to emergency. It's just going to tell you what it's done. Now this is basically the back button. Like I said, you simply go up here, you can see if you have an alarm on the unit. If you have an alarm, you're going to see this here. Little light flashing here next to this little like warning symbol showing you have an alarm. Otherwise, the transfer switch is pretty much self-contained in itself. There's really not much to maintenance on it. Obviously, you want to have a qualified electrician come out, take a look, make sure all the contacts look good. As a generator company, we come out when we maintenance them. We set up a time, obviously, probably after hours or in the time when people aren't living here in student housing, and we would shut it down, make sure everything's transferring right, grease all the points on there, because there are quite a few moving parts inside of the ATS. We want to make sure everything's greased properly where it needs to be greased. All the connections are still properly tight, because with heat and cold, you know, connections do come loose a little bit here and there, so we want to make sure everything's retorqued and done. But that's done once every year, once every 2 years, just to make sure everything's working properly. The best thing you can do for a transfer switch is when you probably exercise it once a month, obviously transfer load, to make sure everything's working properly, if you can. If you can't, it's understandable, but we don't want these things sitting stagnant. We don't want them transferring every other day, but we want to test them out every month to make sure that they're actually going to work and transfer when they're called to do so.
Can I ask a decent question aside from maybe the Kohler here?
Yeah.
When we transfer a load, we have a 15-minute delay that it transfers. And then on the diesel engines, we let it run another sometimes 15 minutes.
Automatic cool down 5 minutes.
So a cool down 5 minutes. So does that also affect the SUT and the levels of that unit?
On a 5 minute, I wouldn't worry too much about it.
Yeah.
The SUT, you're going to see more if you're running hours upon hours. I've seen units with people, because the great thing, we can see how many hours are loaded on the units now. So we can really tell how much they're being put under load. We can't tell what load is being put on it, but we can tell if they're being put under load or not. It's just, that 5 minutes is not going to hurt it. It's just the extended amount of hours. Like, say you run it 40 hours in a year, and 38 of them are unloading. Obviously, you're going to have some soot buildup. You're going to have some things going on inside of there, which is why usually with services, when you guys have your annual services done, things like that, usually a load bank's done, and that's the load bank is to make sure that TPF gets cleaned out. I mean, a load bank is to test the generator to make sure it can handle it, but it's also to clean the exhaust system out, honestly. The biggest thing for DPF is load banking.
Right.
Once a year, get that thing loaded down to like 95%, let it burn for 4 hours, and that'll clean it out. Trust me, you'll see a difference. It'll run better. You'll see the exhaust is actually a lot clearer. Like, you won't see any kind of black smoke or white smoke coming out the top. Obviously, that's the first indication we got soot buildup is going to be black and white smoke coming out of there.
So on the load bank portion of it, with that cool down, you take that shuts off on the load bank during the 5-minute cool down at the end, or does it stay on there?
No, it stays on.
It stays on.
That'll
Okay.
stay on. You're gonna have to manually turn it off.
Okay.
Now, if you're talking about if you go up and run it, like if you're just running the generator
Yeah.
and you're running a load bank, obviously that's controlled by you. You're the one turning it on. You're the one turning it off. Now, during a test, obviously it's going to be a little bit different. If you guys are running a 30-minute test, or you guys want to do it automatically, like the transfer or the monthly runs.
I was curious, not so much for us, but our auto shop here on campus runs it monthly as well, without
Okay.
load. They just test the generator. So the load bank more along the lines of that is what I
So when they're coming in and running it, you're gonna be in control of that cool down. I mean, obviously you're gonna load it up, and then you're gonna let it cool. You're gonna basically, when you guys are ready to shut the generator down, you're gonna turn the load bank off, and then let the generator run for 3 to 5 minutes, just to cool down. All it's doing is cooling down the coils. Those coils on the top are gonna get hot, and it's using the radiator to blow across to cool them down. So that's more kind of up to you. They don't need to be cooled down on these new ASCO, no, this is a Simplex. The Simplex coils and the ASCO coils, the new stuff, you actually don't need much, maybe a minute or two to cool them down. They don't really require much of a cool down anymore like they used to. So, quick function here. This is a button. This right here, you can see right here, press this button, test transfer. So if you ever want to, if you opposed to doing like automatic runs, or you guys coming in and doing it, a quick way to do it is to press this button and do an automatic transfer. That will not have the 5 minutes, that will not have the cool down in it. The retransfer, let's see here, timers. So, let's see here, emergency to normal. During a test, the retransfer time is only 30 seconds. If you're running a test. If you're running during an emergency, during a fail situation, it's 15 minutes. During, like if you were to come here and do a transfer test on your own, it would only be a 30-second time to transfer back. Because we're not worried about normal power. It already has normal power. So it's only going to take 30 seconds.
On our tests here that we do on campus, we test with load for 15 minutes on average.
That's awesome.
Yeah.
I'm glad you guys tested load. So how are you testing it with load, or are you just letting it automatically?
Automatically transfer it, it goes to a system, and then it's timed until it shuts off.
Yeah. So during a test, it would only be a 30-second. It wouldn't be that 15-minute.
Yeah.
Yeah, it wouldn't be the 15-minute. I just need to know time of day and how often you guys run it, and we can set that.
Yeah, good. We would need that information.
Whenever. I mean, today would be ideal.
Okay.
But if you guys don't have it today,
We'll probably work it out and figure it out. Otherwise, good.
yeah. Questions? So, the last thing we're going to talk about is this guy right here. So, this is Annunciator. This is basically just a mirror image of what's going on at the generator. As you can see, we have a set of faults, we have a set of status, and that's how it's going to sound. This is a silence button. Obviously, we're in a room here. Probably nobody's ever going to hear this. Overspeed, high engine temperature, low oil pressure. Overcrank is a shutdown. High engine temperature has a warning and then a shutdown. They're of only about 2 degrees difference. So we're going to shut down at 220. Warnings at 224, shutdowns at 226. Hopefully the generator never gets that hot. Even under full load, that thing should only be like 190, 195. So if you're getting up to that temp, you probably got some block thermostats. More than likely. Low oil pressure, same thing. I think it's at like 24 for the low, and then 22 for the shutdown. Low oil pressure PSI. This thing will probably run about 50, 60 So you start seeing it considerable drop down in the 30s. We know we got some issues we need to figure out. Over speed, shut down. Obviously, you go over, 70 hertz. It's going to shut itself down automatically. Emergency stop is located here too. It tells you if you're in emergency stop. It does show you if you have low fuel. Low coolant level is only a warning. It's not a fault. It's going to continue. Oh, I'm sorry. Low coolant level is a fault. Low coolant level comes in about 30 seconds. If the unit runs, it takes about 30 seconds, and then that unit will shut itself down. It will not let you run with low coolant level. There's a sensor up at the top that basically, as soon as it starts, it's going to look for that coolant. If it doesn't see it, it's going to shut the unit down. It's just protective over the engine. That way we don't blow up the engine. Low coolant temperature is just a warning. That is just simply so you guys check the block heater. It's going to give you an alarm telling you, hey, temperature's low, come check me out. Low cranking voltage, very hard to simulate, but if your batteries ever do get that low and it starts cranking and the voltage dips below 18 volts, it's going to send an alarm saying, hey, low cranking. Battery voltage, high or low, it's going to give you an alarm. If the charger goes wonky and things go really high, starts charging over 30 volts or something like that, which I've never seen them do. Or if you have a low battery, which would signify a battery charger. Battery charger is going out. You may not have a battery charger fault, but you may have a bad battery charger 5, 6, 7, 8 years down the line, Common fault, this is going to come in either a amber color or a red color. Red is shut down, amber is the warning. This is always going to flash no matter what. Whenever you hit the e-stop, you hit turn the unit off, this is going to start flashing something. This is your status, system ready, communication status. Green is where we want to see it 100% of the time. We don't want to see any other lights on, like when it's just sitting here, this is what we want to see. System ready, communication status. This will go light up when the generator's running. This will only enunciate when you have, let's say we go and turn the generator to the off position. It's going to tell you here, not an auto. It's going to start flashing system ready. It's going to start flashing the common fault, like a yellow, amber color here, common fault. EPS supplying load means emergency power system is supplying load. So if unit's running, power went out, everything transferred, unit sees load, it's going to tell you here EPS is supplying. It'll also tell you that in the control center as well. Like I said, this is just a monitor. This does not connect to any alarm system. Does not connect to anything. This is just a mirror image of what's going on there. So sometimes when the unit's running, it's easier to come in here and see what's going on. Not quite as loud. Easier to get to. One door, open up. Okay. Let's see. I'm supplying load. System's still ready. Generator's running. You look at the ETS. It's okay. I've got emergency power here. You know you're running an emergency power. And you can always silence it. So if this goes off, simply come here, press the button, and it'll silence it. Any questions? Good. Questions back there?
That's the only panel that is remote function. You don't have one in open space where it's up to the
That's why it's hooked up to the fire alarm control panel. So we have a separate alarm board in there that's connected to the fire alarm control panel that's going to give you your faults. I had the same question. I saw it. So it is tied in with the fire alarm control panel, the FCC. So this is just simply a monitor. Any other questions? No? Good?
Yep, and
Okay.
cut.